Hi everyone, welcome. Here are the big takeaways from this topic on controlling extraneous variables and the chapter 11 section called confounding and obscuring variables. The first big takeaway here is about control processes in research design that remove from an experiment the influence of extraneous variables, one at a time, each extraneous variable. To the extent that the influence of extraneous variables can be removed from any experiment, the true cause and effect relationship between the independent variable and the dependent variable can actually be perceived. Can be seen clearly. Remember, this is the logic of experimental design from an earlier chapter. So how exactly do we remove the influence of extraneous variables? That's our topic today. Through what we call control processes, three favored techniques in particular. Let me say that the first is random assignment to comparative groups of your independent variable. Random assignments, that means what it sounds like. We randomly select people out of the sample, the larger sample, one at a time, and one person goes to group number one. Here's the larger sample. One person goes to group number one person goes to group number two, the next person goes to group number one, the next person goes to group number two, and so forth. This is randomly taking people from the sample and assigning them to the comparative groups of my independent variable. Now I'm talking about before the experiment begins. So this is like the early timeline where you've gathered the sample of participants, and then we're deciding which participants will be assigned to group 1 versus group 2, or be assigned to your experimental group and your control group. Random assignment is the first choice. Now our goal here is to avoid a clustering of participant characteristics that we specifically identify as an extraneous variable. And random assignment to groups really reduces this possible clustering. As a result of random assignment, take our sample, one goes to one group, the group one goes to group two, one goes to group one goes to group two. As a result of this kind of random assignment to comparative groups, we're just not likely to see the clustering of any one specific characteristic in group 1 versus group 2 of our independent variable. Imagine an extraneous variable worried about is gender, and you want to control for its influence on the outcome of your study. So we would want to avoid gender clustering, that is, clustering the majority of women in group 1 and far fewer women in group 2, or the other way around. By random assignment alone, you'll probably not see clusters like that. That's why random assignment is always our starting point, our first attempt to control an extraneous variable, just randomly assigning people to comparative groups of the independent variable. And remember, the logic of experimental design says that if two comparative groups are otherwise equal to each other in characteristics, in this case equal in gender, for example, equal representation of males versus females, then any differences observed in the outcome scores for the dependent variable must have been due to the independent variable. That's the logic of experimental design, right? It was the independent variable that caused changes in the dependent variable and not some other extraneous variable like gender in this example. Now, after random assignment to comparative groups, there's two most common ways to control extraneous variables, but they all have the same goal, fulfilling the logic of experimental design. The first one is to explicitly balance or equalize characteristics across experimental groups, or number two, to remove extreme, unusual characteristics of certain participants, just remove them from the study completely. Let's look at our first control technique. To balance or equalize characteristics would mean that I go out of my way to carefully balance my two comparative groups of my independent variable on a specific extraneous variable, such as ethnicity or race in a different study. I may choose to balance the comparative groups of my independent variable to ensure that race, for example, is equally represented in my comparative groups, thereby removing the likelihood that race might offer an alternative explanation for any differences observed in outcomes for my dependent variable. Here, I fulfill the same logic of experimental design by making the two comparative groups of my independent variable as equal to each other as possible, that is, equally representative of different races in this example, removing the likelihood that race, my identified extraneous variable, ethnicity, race, has any influence, removing the likelihood that it has any influence on the observed outcomes for my dependent variable. So there's random assignment, then there's balancing groups. The last control technique is to remove extreme characteristics. Think of these like outliers of an identified extraneous variable, which, if included in our studies, could really throw off the results. For example, in a study of the effectiveness of after-school tutoring program in an elementary school, I probably want to remove the extreme characteristic of being a straight A student, or the extreme characteristic of being a mostly F, straight F student. A students in my study would have too little room to show improvement from my tutoring program, so I would exclude them. And F students may be struggling with issues that go beyond the effects of my tutoring program, so I may choose to completely remove from my study A students and F students. In other words, they never enter the sample to begin with, the sample that's then assigned to comparative groups. I just remove them completely. It's another technique for controlling an extraneous variable. For example, in a study of the effectiveness of an after-school tutoring program, I probably want to remove my straight A students and my straight F students. That is, I recognize my sample has A students, B students, C students, D students, F students, but I know that A students have too little room for improvement and F students may be struggling with larger issues. So I may choose to remove them completely from my study sample before the experiment ever begins. As before, our goal in controlling extraneous variables, guys, is to avoid clustering of either mostly A students in one group or mostly F students in another group, group 1 versus group 2 of the independent variable, because clustering of characteristics could influence later differences observed in outcomes for my dependent variable that undermines the logic of experimental design. So guys, here are my 3 primary ways to remove the influence of extraneous variables when we're designing an experiment. These are all used, this is also called how we control for extraneous variables. The 3 big takeaways from this, the 3 techniques. Number 1, random assignment to comparative groups. Number 2, we balance certain characteristics across our comparative groups of our independent variable. Or number 3, sometimes we just remove extreme characteristics completely of certain participants, remove them from the sample. These are the big takeaways from this topic, guys. Thank you very much.